Day 5 Car
Welcome to Day
Audio
5
School.
Car Audio School, where you are going to learn how to install your own product, become a technician, or start your own business. This is my online resume for entertainment and educational purposes only. And my goal is to help you not have to go into a shop anymore. You can do it yourself. If you do have any issues, we'll talk about that later. I'm setting it up to where you can come see me in Phoenix, Arizona, or one of the neighboring cities. And if you are not able to take care of your vehicle on your own through my instruction, you can actually bring it to me and I will help you fix it, of course, for a fee, but I will help you get it together. So yesterday we talked about or finished up on Ohm's Law. We didn't talk about Watt's Law. However, that was part of talking about power. So just to finish up on Watt's Law, we'll talk about that for a brief moment, and then we'll go into series and parallel circuits because they kind of dovetail into the next. So wrapping up on Watt's Law, we'll think about it like a light bulb, and I'm sure everybody remembers the big actual light bulbs that we used to put in our light sockets and our kitchens and our bathrooms and all that. Well, those had a certain rating on them, and sometimes they'll say 25 watts. Sometimes they'll say 50 watts, 60 watts, 100 watts. Now, this is going to come in importance when we start talking about speakers, how many watts they are, and then even more so when we start talking about amps, how many watts they are. And what we need to remember is watts is the ability to do work, which is what our amps are doing, work, which is what our speakers are doing, work. The best way to think about this is remember the water wheel from our current analogy. That is flowing through the pipe, hitting the water wheel. The water wheel in this case would be our amplifier doing the work. So let's say that we have a 100-watt amp that is going to power 4 speakers. That amp, then let's say the speakers are 100 watts also, that amp is not able to do enough work, pinwheel spin, to push power to the speakers. Even with that being said, if you have a 1,000-watt amp, and we'll call it a monoblock, but that will save definitions and things for later. If you have that on top of or pushing power to, we'll say, 2 500-watt amps, what we're talking about is peak power. But what we need to consider, and we'll talk about this later, is RMS, root mean square power. Now, not to get technically specific in all this, root mean square just means constant power. So how much power can these devices receive at a constant rate without blowing up? That's what RMS means. It's good practice to match the RMS of the, we'll say the speaker or the subwoofer, with the RMS of the amplifier, just to make sure that we have enough headroom not to blow them up. So if the amplifier is putting out 1,000 watts and the 2 speakers are at 500 watts each, that makes for 1,000, but there's no headroom. So that's why they say the RMS. So let's say the constant rate of that speaker is 250, Now we're at 500 consistently without blowing up that speaker. You can think of it as a 12 o'clock dial. As long as you are sitting at that 12 o'clock dial at 250, turning up your amplifier, once you go to 1 o'clock or 2 o'clock, you're now inside of that headroom that will increase the wattage up to 300 or 400 on that speaker. Therefore, the continuous use of that speaker will come down because you're outside of the RMS range. So, with that being said, let's talk about series and parallel real quick. I am going to move this to my other screen so I can see it better. And before I do that, just to recap, the more watts you have, the more power you have. And we'll talk about how to measure that later, because I think that's important to know about. So we'll get into series and parallel circuits. So think of 20 people standing in line, or when you were in elementary school and everybody had to hold hands to go into the classroom. That would be a series circuit. Everybody's in one line and the electricity can flow down that direction. If any one person were to break out of that line, that circuit would be broken. It would no longer be a series parallel, or at least it wouldn't be a connected circuit, but it would no longer be a series parallel, or a series circuit. Now, a parallel circuit, you can think about that as back in the day on the TV show The Price is Right, they had this game called Palinko. And you take the chip and go up to the top and you drop it. And it had all these little pegs at the, whatever that is that they drop. We'll call it the disc that they dropped, would fall down and go really anywhere. It's variable. It doesn't have a rhyme or reason where it goes, but just for the sake of this example, that would be a parallel circuit. So another analogy I can give you is back to our water hose circuit. Let's say at the faucet you have your voltage and your current, your water flowing through the pipe, but let's say it branched off into 3 or more, right? So you have 1, 2, 3 directions that the water or the current flow, you can think of that, like a current on a river, has different directions it can go now. So any break, we'll see if I can do that, any break in that connection does not stop the water from flowing or the electricity from flowing down another direction. This will be important when we start to series and parallel speakers and electrical connections for sound. It can either go multiple directions, or like a 4-channel, for example, or it can only flow down one tube. We'll say like a single subwoofer or a single large speaker. So that's pretty much it for today. If I were to give you another analogy, like for series and parallel, that would be, series would be a single lane highway. It can only go down one direction, whereas parallel would be a multi-lane highway. So you have 5 or 6 lanes that multiple cars can go down. You can actually push a lot more current or a lot more water down that direction than you can a parallel or a series connection. Um, just in hindsight, thinking about this, this is also why the phrase pressure burst pipes. Well, this is also why wires glow if you push too much power through a small gauge wire, and gauge is just the measurement of size for the wire. If you push it down too small a wire, well, we'll think about it like a traffic jam, except for this creates more heat on that wire. The wire becomes the fuse. So you also have to, match up your fuses too. But this is why we use larger gauge wire if we're going to power multiple power hungry accessories or devices, so that wire doesn't become the fuse, and the actual fuse does what it's designed to do, to break in the case that there's a power surge or traffic jam, which will burn up the wire. So that's it for today. I'll be back tomorrow to explain more, and I'll put all my information down below. Just to reiterate, we will get to a point to where we're at my desktop and I can actually show you visual representations of what it is I'm talking about. Donate, donate, donate. Tip your technicians because they work really hard at their job. Currently, I am working to get All Data Mitchell 1 and DirectTech on my computer, so you can ask me where something is at or how to dismantle something, take a bumper off or whatnot. And yeah, we'll keep on pushing and making this happen. See you tomorrow.